You see, while using sheet metal, um, first thing what we need is a closed figure like this. Okay, not just a rectangular or square. It can be of any shape. Okay, of the parent metal or the parent base flange. And these are the tools which we have. And the uh, first toolbox is wall toolbox. Then this is our bending toolbox. Then we have our cutting and stamping toolbox. Under stamping itself, there are different options which is available here. All of these are, yes, all these are predefined stamping tools. But in SolidWorks, what we had was not predefined stamping tools. We have to create our own stamping tools and use that. But here, all the shapes are majority of the shapes are predefined. Okay, okay. Then first of all, we have to set the sheet metal parameters. For that, under walls, there's an option called the sheet metal parameter. Click on that, and we can set the default thickness, bend radius. And here I'm giving the thickness value and default bend radius as 2. Bend radius as 2. Then I am depending upon the value which we give here, the bend elements will be calculated. Okay, that is equation driven. That's why you can see some f of x something like this. Yes, mathematical calculations are running behind. You see, if I'm changing the value of sheet metal thickness or bend radius, that will change accordingly. Initially it was 3 point something. Now it is zero point 0.2. Okay, that depends on the sheet metal. And here we can give the relief parameters. Bend relief. Okay, that means when we give some bending and all, the corner portions, how the corner portion should behave, or should there be some gap between with should can you see this thing? Is it? Ah, mm. You should. I'm just using my headset again. Tell me if it is clear. Okay. Is my voice clear? Hello. Is it clear? Okay. Okay, we can, depending upon our criteria, we can adjust the relief shape. By default, it will be minimum with no relief. Okay, and we have given thickness and bend radius, giving okay. Only after that, all the tools will be getting activated. Do you notice? Okay. The first tool which we have to see from here is wall. There is one thing called the recognize, which is similar to our convert to sheet metal. That means if we are creating some solid geometry and we have to convert that into sheet metal, we can use recognize. Uh, Otherwise, wall. Majority of the time, we'll be using on wall and click on this thing and you see the base feature is created. Base feature is created. We haven't given any thickness, but we have already given that on the sheet metal parameters. Okay, no, not possible. Only after giving the thickness, uh, these options will be active, right? That options won't be active without that thing. Okay, then we have wall on edge. Wall on edge means consider we have um, some some coverings like you have seen our CPUs or inverters. Those all are sheet metals. Okay. Uh, then there are many parts are there. All vehicle bodies. Okay. What I was going to say was cover. Okay, create wall on it. Select the wall, and if I'm selecting these two edge, that two walls will be created, and there is no relief because we haven't provided one, uh, right? Okay, here we can control the angle and height. Okay, and the distance and the height is measured according to this conditions. Can you see these things? Okay. These are our same as our SolidWorks options. Okay, everything will be same, some interface difference only. Okay, and but these things are not in SolidWorks. These stamping operations and all. Okay, then we have another tool called the extrusion. Just like our SolidWorks extrude, here we will be creating a sheet metal from a 2D sketch. Okay, directly from a 2D sketch we can create our sheet metal. Yes, different from converted sheet metal. That is another thing. I'm giving some dimensions so that okay, this is our base sketch. First of all, define the parameters. Okay, I'm giving thickness and the bend radius as one. Okay, using extrusion. Extrusion. Select the sketch. Okay, there's a in two ways we can create, either using either this as a single extrusion, or if I'm using exploded mode, uh, each flange will be represented by as separate operation. And if I'm giving automatic bend, here it will create bends, automatic bends, you see in this corner. If it is off, it will be like this. Okay, and the thickness, whether it is from in one direction, if we have to invert the direction, I mean invert the material side. We should have 1 minute. I am having a, or hello, ക്ലാസ്സിലാ അല്ല അല്ല ഇല്ല ഇല്ല ഞാൻ ഇങ്ങനെ പെട്ടെന്ന് ക്ലാസ് എടുത്തോണ്ടിരിക്കുകയായിരുന്നു. അല്ല, ക്ലാസ് എടുത്തോണ്ടിരിക്കുകയായിരുന്നു. ഞാൻ ക്ലാസ് ഉണ്ട്, ഞാൻ എടുത്തോണ്ടിരിക്കുക, വെച്ചോ വെച്ചോ. ആ ഹലോ. If we want to invert the material, we can do this. If we have to provide the distance as a mid plane, just like our mid plane in both direction, here is the option sketch at the middle position. Okay, you're okay, right? While comparing with the SolidWorks, I hope you don't you haven't forgot the SolidWorks tools. Oh, that fantastic. Okay. Uh-huh. But the one which you sent me was not bad. The what that is, you sent me the one staircase, right? Stair. Ah, then okay, then don't care what I said. Okay, then we have bending options. Sorry, swept walls options. under walls. Sept walls, there are different purposes. Okay, for set walls. What was those? The similar one we did in SolidWorks also. Ah, yes, yes, right. Some bending on the edges. It can be for safety concern, or for giving some strength. Okay, if we are bending here, it will these edges will be having some certain strength. Okay, here everything will be highlighted like this. Okay, every options, every control, every parameters which we can control can is previewed like this. Okay, so there is no there won't be any confusion with that one. And it is up to all. Here what we can control is the radius, this radius, and the length of this thing. Then we have hem. I think in SolidWorks also the same name is there. Hem. Here we can control this radius, this length, and then we have a teardrop. In the teardrop, the only difference is that we can control the angle also. This along with this radius, we can control that angle also. Okay, you see. Mm. Sorry, not we are not controlling the angle. Instead of coming straight, it is going at an angle towards the parent metal. I didn't got what. No, we don't have to measure. We don't have to measure anything. Depending upon the length, the position adjusts. Okay. Depending upon this length, the position you can see when I increase the length, it is getting longer, or the arc is becoming shorter. The sector of the arc is becoming shorter. Okay. This is one of the common shape which we see in sheet metal. Okay. Then we have one tool called our user plans. In user plans, what we do is that it is very similar to our meter flange and SolidWorks. We have to create the cross section. Okay, cross section has to be user defined. Mm, uh, uh, I'm giving some coincidence with these two. You understand with what all things I give coincidence. Yes, tell me. Yes. User flange here as the spine, this one, and as the profile, this one. It will be following the profile, but why it's not following? There has to be a tangency. Okay, there has to be a tangency while creating this thing. There has to be tangency. Okay, I will show you. I will show you. Instead of coming it inclined, it will be better. Otherwise, there might be some problems with the bendings which is created. Okay, there is some default bending for sheet metal, right? If that is more than this thing, that will be problem. Or by adjusting that angle, this angle like this also we could have managed. Yes, sir. Spine There is some other problem issue. Let me see what's that. But okay, the problem was with this flange length. Okay, that length has to be long enough to accompany uh, to hold this radius. Okay, that is the problem. Okay, then we have when we cutting stamping tools. In cutting stamping tools are just like our hello. Ah, like our extrude cut, right? We used an extrude cut operation for sheet metal also in SolidWorks. The similar way we can cut here. It's called cutout here. Okay, we in cutout what we need is we need actually a cross section which has to be cut. Okay, this is a section. Exit, cut out, and select the profile. Okay, understood. Okay, Vishnu. Okay. Then we have hall. Hall is nothing but a customized hut. Okay, just a hall. Here it can be any cross section, but here it is really hall. And if we need, we can provide the thread definitions and all, which is similar to our hall in feature. What we learned in feature. Then we have a circular cutout. In circular cutout, what we do is that we can give cutout in this curved regions. In this curved regions, we can provide a cutout. Circular cutout, select the profile and give the radius. Okay, and then we have one tool called flatten. You know, flatten. That is in SolidWorks here. Fold and fold. If we unfold, we can see how that development view. We call this as the development view. Okay, how the development view will be looking like. Okay, sorry for. Then to again click on the same thing to fold. Okay, I just used to show this thing, and then we have a corner relief. Corner relief, what we do is that let me again provide a wall here. Yes. Then I'm just again flattening or unfolding. You see here, it's a sharp corner, right? There are chances if the sheet metal thickness is above certain range, there is chance that that portion can have uh, some problem while bending. Okay, at that time, what we do is that we give a corner relief. Select corner relief and click on the support, this support and this support. And here we can change the shape, either circular shape or a square shape, or we can provide a user profile. Under the user profile, click here, select the face, and draw the profile which we need. Okay, it can be anything using our spline or arc or circle or. After that, give exit. Okay, you see, this is corner relief. Then we have our corner and chamfer option. I'm just folding it again, and I can see our chamfer and corner option. And corner option, what we do is just like our fillet. Okay, and chamfer is our chamfer itself, right? Same thing. Select this thing, give the angle, and give the length. Either it can be length or length angle, as we have seen in many fillets. Okay, then we have cutting stamping tool. I'm not going for that one. That's a long list of tool. Let it be there. We are going for this one. These things you know actually. Transformation features. Transformation features. Mirror. You know mirror? Do you know mirror? Good. Then we have uh, our patterns. Circular pattern and rectangular pattern. You know. What about user pattern? That's also we have studied, but with some other name in SolidWorks, and same name in user pattern, and same name in CATIA also we have learnt. We provide it's a user defined thing. We provide some sketches like this. Uh, sorry, giving points, and if we want to locate the point, we can locate it using our dimension. Yes, mention that sketch here. Go to user pattern, select the feature. First of all, select the feature. Okay, that is one maybe one problem with the CATI. We can say Mm, not problem in SolidWorks. Both the way we can do. You see, after that, select the sketch. It's on the respective positions, right? User pattern. Then we have right. Not curve-driven pattern. Curve-driven pattern is we will be providing some curves, some spline or arc, and the name for this is sketch-driven pattern. Yes, that is curve through XYZ, and it's okay. I am very happy that you remember even that option also. Okay, okay. You see, then we have these moving options, the same moving options which we studied under our part design. Yeah, right. Okay, yeah, isometries. Are you okay with these things? Okay, fine. and you forgot. Okay. Okay. Then you see, then we have rolled walls. Rolled walls, freeform surface, and Hooper. I mean, this the first one was Hooper. Okay, Hooper, freeform surface, and rolled wall. Rolled wall is nothing but to create formed shapes, especially yes, no, not boundary or loft. I'll tell you. This thing has something to do with the surface workbench. You see, it's a conical shape, not just a conical shape. I am making it into a conical surface. Access of the if I'm not able to get the access from here, just a right click on this revolution axis. That is possible everywhere. Okay, then if you want, we can create our own axis depending upon the options, which I think you know. Then and then okay, then we have you see is an axis, and I'm giving 180 degree, sorry, 360 degree. You see, now it is a surface. We can convert into a sheet metal. Under generative sheet metal, give the thickness and all as required. Now, okay. You see, go to Hooper, select the surface, select a reference wire, that is the line, or it can be any other line. Okay, not just the line which we used to revolve. Then select an invariant point. As invariant point, it has to be either endpoint of either of the endpoint of the line. I'm selecting this one. You see, and give preview. I have created a sheet. Understood. If I'm just unfolding that, I can see the flattened view, a development of a cone. Okay. What you asked? Yes, yes. Yes, it's more than that. It is a development of a cone. That is a very useful thing in sheet metal industries. Okay. Uh, if we are doing it manually, it's not that easy. Uh, I remember one while I was doing one of my apprenticeship days, there was a machine which had a conical support or something. I don't remember such support. And that due to time and corrosion and all, it got damaged. Okay, they had only some a certain piece of the cone, and from there they had to create the development of the cone, but manually. That's a very time. That was a very time consuming process. Okay, majority of them forgot how to create the how to manually draw the cone development of cone. If you know these tools, just a part of that that sheet metal, that part is enough. Just just a portion of that is enough. From there, if you are getting some dimensions, we can develop it, right? If you are getting some angles and all, we can develop it. Then we have freeform surface. Uh, Under freeform surface is also related to our wireframe and surface design. You see, here it is not just a cone, but any shape. Let it be any shape in surface that can be converted into sheet metal. freeform surface. You see? Okay. Then we have a tool called rolled wall. It's nothing but it's for creating an sheet metal from a sector of a circle. Sector or segment, what we call that? I actually forgot. Okay. Here also, if you want to flatten it and give some holes and all holes or any shape cut, give any shape cut. Okay, not just not just a hole. Yeah, man, yeah, man. അതെ വിഷ്ണു 1 minute. അതെ ഞാനിപ്പോ കഴിയും പോരാ. I will go on. I am. നീ ക്ലാസ് ബ്രോ Vishnu 1 minute. You remember the location what we said? Near Kamalam. Kamalam by Mumbai. Kamalam Hotel. Nearby Kamalam. Opposite the Kamalam. Opposite Kamalam. സ്ഥലത്തിന്റെ പേരെന്താണ് പഴുവട്ടി ആ ബിരിയാണി 2 കിലോ ബിരിയാണി 2 കിലോ എന്തുണ്ട് നമ്മള് 3 പേരല്ലേ ഉള്ളൂ எனக்கு குவாண்டிட்டி சைஸ் எவ்வளவுன்னு தெரியல 1 கிலோ 2 பேருக்கு ஒன்னும் தர மாட்டாங்க 2 கிலோ കഴിക്കാം പൈസ ഉണ്ടായില്ല പൈസ എടുക്കാം മെൽബിന്ന് വേണം കൂട്ടലാൻ നോക്കാം അതിനൊക്കെ ഉണ്ടാവും hello Vishnu. Okay. You see, I have created a hole here and I am just patterning that hole. Okay. Using rectangular pattern, I'm just patterning that hole in X and Y direction. Okay. After that, I am just refolding that. It will be like this handle. Okay. This might be useful sometimes. Okay. Okay. These are some sheet metal operations. Vishru, I think we can stop for today. Just practice this tool also.